Hey guys, this is part 2 for paper 4H from November 2009, sorry. Okay, so let's get back into it. Alright, so in question 10A, there's information about the rainfall in Singapore in December, and there's a table of rainfall and the number of days it rains in that category. So you have to find out the total rainfall in December in December basically. So now how do you do that? Basically what you want to do is multiply each of them because it rains this much for 23 days. So the total rainfall for the total amount of rainfall would be this times this plus this times this plus this times this plus this times this. Because basically, let's say it rains 10 millimeters on one day, then it rains 2 millimeters on one day, 2 millimeters on the next 2 days. It would be 10 times 1 plus 2 times 2. Right? So that would be like 14. But in this case, now you have a range of values. You don't have like just it rains 5 millimeters one day. It says that it rains 0 to 10 millimeters one day. So what amount of rainfall are you going to take? It's basically the amount you're going to take is the midpoint value. And how do you find this midpoint value? It's nothing but the middle number in the range. So the range goes from 0 to 10, right? So all you got to do is 0 plus 10 divided by 2, which is 5. So the middle range is 5 for this. From 10 to 20, it's 10 plus 20 divided by 2, which is nothing but 15. So the midpoint value is 15. And so on. So it's 25 and 35. So now you have like a kind of value for an estimate of like the average amount it rains on these days. So all you got to do is take this estimate number, which is this number, and then multiply it by the number of days it occurs. So all you're going to do is do 5 times 23 plus 15 times 3 plus 25 times 2 plus 35 times 3. And you're going to get 115 plus 45 plus 50 plus 105, which is equal to 350. So there's 315 millimeters of rain in December on average. Sorry, approximately 350 millimeters. Okay, 10B, we're given a histogram showing information for the rain in November, which has 30 days. And they're showing basically a histogram of frequency density against rainfall. Now what is frequency density? First look at this equation over here before we start this question. Frequency density is equal to frequency over class width. Now frequency is nothing but the number of days in this case, because let's say rainfall occurs like 23 days, so that's the 23 is the frequency. And class width is nothing but like the range of values. So for example, in the previous question, let's look at this table over here. For example, over here, the range of values is from 0 to 5. So the class width is nothing but 5. The range of values here is from 5 to 15. So the class width here is nothing but 10. So that's what class width is. It's just basically the range of values in which the thing lies in. The whatever you want to call it, the rainfall or the changeable value. Okay, so now if you rearrange this equation over here, you're going to get this. Frequency is equal to frequency density times class width. And that's nothing but, if you think about it, if you're multiplying the y and the x-axis, basically what you're getting is the area. So this total area is nothing but the frequency, the total frequency. And according to the question, you're being told that the total frequency is 30. So that means that the total area should correspond to the total frequency. So in this case, you got to count the number of boxes. Basically, if you count all of them, they add up to about 300 boxes. Sorry, 300 boxes. And that corresponds to 30 frequency, 30 days. So how much does one box correspond to? And that's what you're trying to find out. So you cross multiply, you're going to get 300x is equal to 30, and x is equal to 30 over 300, which is 0.1. So one tiny box here corresponds to a frequency of 0.1, right? So now we got to find out like a kind of scale, a scale for frequency density, meaning like you can see this is labeled, this axis is labeled, but there's no labeling here. So we got to come up with that so we can solve this question then. Actually, sorry, we don't need to actually come up with a scale for frequency density because we can solve this question directly. If we know that one box over here is 0.1, right? To figure out the total frequency of the whole bar, all we have to do is count all the boxes and multiply it by 0.1. So just in this case, in this bar, there are 190 boxes. So all you got to do is 0.1 times 190, and you're going to get a frequency of 19. So that means in the 0 to 5 category, which is this category, or this bar, there are 19 days where it rains in that category. And do the same for the rest. So over here there are about, I think, 40 boxes. So it's nothing but 0.1 times 40, which is 4. So it rains 4 days in this bar. Next, we're going to deal with the last bar. You just count the number of boxes. I think there are about 70 boxes. So it's 0.1 times 70, which is 7 days. So it rains 7 days in that category. Okay, question 11a. You're being asked to find the highest common factor of 64 and 80. Now before we do this, let's split 64 and 80 into their prime factors, because we can't solve this question without splitting them into their prime factors. So let's take 64. 64 is divisible by the prime factor 2, and you're going to get 32. This is further divisible. 32 is further divisible by 2, and you're going to get 16. 16 is further divisible by 2, and you're going to get 8. 8 is further divisible by 2, you're going to get 4. 4 is further divisible by 2, you're going to get 2. And 2 is further divisible by 2, and you're going to get 1. And that's what you're aiming for. You're aiming to get the 1. So basically, 64 is comprised of these numbers multiplied together. 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, times 2. So 2 to the power of 6, right? Now, let's do 80. Alright, so 80 is divisible by 2, and that's going to give you 40. 40 is divisible by 2, that's going to give you, 20. 20 is divisible by 2, that's going to give you 10. 20 is divisible by 2, so that's going to give you 10. 10 is divisible by 2, so that's going to give you 5. And 5 is divisible by 5, and that's going to give you 1. So 80 is nothing but 2 times 2 times 2 times 2 times 5, or 2 to the power of 4 times 5. Alright, so for highest common factor, when you have them split into their prime numbers, what you're looking for is the lowest amount of each number they have in common. Of each number they have in common. Alright? So in this case, what do they have in common? They have the 2's in common, right? 2 and 2. But you're looking for the lowest amount. They don't have 5's in common, so forget the 5. But you're looking for the lowest amount they have in common. So if you look at this, 2 to the power of 6 and 2 to the power of 4. What is the lowest amount they have in common? It's nothing but 2 to the power of 4. So that's 16 as their highest common factor. Alright, so for 11b, you're being asked to find the lowest common multiple of these. So again, you have them split into their prime factors. And when you have them split into your prime factors, what you're looking for is the highest amount of each number they both have. So in this case, 64 has 2's, and 80 has 2's and a 5. So you're looking for the highest amount they both have. So what is the highest amount of the 2's they possess, both of the numbers? It's 2 to the power of 6. And what is the highest amount of the 5's they possess? It's just 5, because only 80 has 5. So all it becomes is 2 to the power of 6 times 5, and so that is 320. Okay, well, question 12a is really simple. You're just being asked to expand these brackets. Now I hope you remember your expansion laws. You multiply each term by each other term. So it's kind of like this, right? So what's p times p? It's p squared. 7 times p times negative 4 is negative 4p. 7 times p is positive 7p. And 7 times negative 4 is negative 28. So p squared minus 4p plus 7p is plus 3p minus 28. That's your simplified form. Okay, you're given two expressions, 4x cubed y to the power of 5 times 3x squared to the squared y, and you're being asked to simplify it. So all you got to do is multiply this out. So first of all, we're going to deal with the constants, and basically it's 4 times 3, so it's 12. Next, we're going to deal with the x's. So x to the power of 3 times, whenever you have x to the power of n times x to the power of t, and their base, these exponents being multiplied together, and their bases are the same, all this becomes is x to the power of n plus t. So using this, we're going to say x to the power of 3 times x to the power of 2 is nothing but x to the power of 3 plus 2. Now, same thing for y. We'll deal with the y's now. So y to the power of 5 times y to the power of 1, or y, is nothing but y to the power of 5 plus 1. So this becomes 12x to the power of 5, y to the power of 6. Alright, so question 12c is a bit more complex. Before we do this, I want to show you this. X to the power of n, the whole thing to the power of t is nothing but, you just multiply these together. Alright, so you get x to the power of n times t. Now, x to the power of 1 over 3 is nothing but cube root of x. X to the power of half is nothing but square root of x. It's like that. It's basically this number over here becomes the cube root here. Alright? Now, x to the power of 2 over 3, if you use this law, can be simplified to x to the power of 1 over 3 squared. So it becomes cube root of x squared. Okay? So now that you know all of this, let's solve this question. You have 26q to the power of 6 to the power of 2 over 3. So first of all, let's deal with the constant. So it becomes 27 to the power of 2 over 3, which is nothing but cube root of 27 squared, according to what I explained over here. Remember, I drew it there. Alright? And q to the power of 6 to the power of 2 over 3 is nothing but q to the power of 6 times 2 over 3. And we're dealing with the exponent now. I mean the letter now. So what's 27 cubed? 27 cubed is nothing but 3. And 3 squared, q to the power of 6 times 2 over 3 is nothing but 4. So it becomes 9q to the power of 4. Alright, so question 13, you're given two quadrilaterals, and they say that quadrilateral P is similar to quadrilateral Q. Now what does that mean? Similar. Basically, similar means that all their corresponding angles are equal. So this angle is equal to this angle is equal to this angle is equal to this angle, and this angle is equal to this angle. And what does that mean? So what if their angles are equal? What does that mean we could do with them? Basically, if this side and this side, the ratio of this side and this side is equal to the ratio between this side and this side, which is equal to the ratio between this side and this side, which is equal to the ratio between this side and this side. So it means that we can use their ratios of sides to find unknown sides that we don't know. And this is going to help us solve question 13a, which is asking us to calculate the value of x. Now x is over here. So first of all, we need to take a ratio of two sides which we know already. And what are those two sides? It's basically 15 and 12. These are two corresponding sides we know already. So we're going to take the larger quadrilateral to the smaller quadrilateral, and we're going to say 15 is to 12. And we're going to find out x. So what side corresponds to x? It's nothing but 18. So x is to 18, because larger is to smaller. So now all we got to do is put this in an algebraic form, and it's going to become 15 over 12 is equal to x over 18. So x, multiply both sides by 18, is equal to 15 over 12 times 18. And so x is equal to 22.5 centimeters. Alright, so 13b is asking you to calculate the value of y. Now again, we're going to do the same thing we did in the previous question, which is compare the larger quadrilateral to the smaller quadrilateral and compare their sides since they're similar shapes. So basically, we're going to take a ratio of a side we already know, and we're going to take the same ratio as before, which is 15 is to 12. And then we're going to do, what side corresponds to y? It's nothing but the 20 centimeter side. So we're going to do as 20 is to y. So now putting this in a algebraic format, you get 15 over 12 is equal to 20 over y. So multiply both sides by y and multiply both sides by 12. You're going to get 15y is equal to 20 times 12. and then if you divide both sides by 15, you're going to get 20 times 12. Y is equal to 20 times 12 over 15. So y is equal to 16 centimeters. Alright, so 14a is asking you to complete the table of values for x cubed minus 3x squared plus 12. And you're given x values, and you just got to find their y values. So all you got to do is substitute the x values into this equation. Alright, so first of all, let's take minus 2. Y is equal to minus 2, we'll substitute all the x's with minus 2, cubed minus 3 times minus 2 squared plus 12. Now minus 2 cubed is nothing but negative 8, because minus 2 times minus 2 times minus 2 is minus 8. Minus 3 times negative 2 squared is nothing but 4, and plus 12. So this gives us minus 8, minus 12 plus 12, so it gives us minus 8. So that means that x equal to negative 2, y is equal to minus 8. Now we'll do one more, and then I think you can understand the whole story of this. Okay, so next one is 0. So all we got to do is substitute 0 into this equation again. So we're going to get y is equal to 0 cubed minus 3 times 0 squared plus 12. 0 cubed is 0, minus 3 times 0 squared is nothing but 0 plus 12. So the answer is plus 12. So when x is equal to 0, y is equal to 12. And I'll just fill in the rest of the details. Yeah, so the next answers are 10, 8, and 12. Okay, so you have these values of x and y for the function x cubed minus 3x squared plus 12, and 14b is just asking you to draw the graph of x cubed minus 3x squared. So first of all, just plot these points. So when x is negative 2, which is here, y is negative 8, so go down to negative 8, and that's somewhere here. Sorry, here. So just go across where they meet, that's one point over there. Then when x is negative 1, which is here, y is 8, so you go up, and your other line will be there. So your next point will be there. Then when x is 0, y is 12, so that's somewhere there. Then, and so on. So I'll just plot the points. Okay, so now that you have all your points plotted, all you got to do is draw a straight line, like a line through all of them. Put arrows on either end because the line can go on forever. And just label your graph y is equal to x cubed minus 3x squared plus 12. And that's it. Alright, so question 15 is about circle properties. I can explain the circle properties, but it would take me too long to explain it, so I don't think I'm going to explain it. I'm just going to tell you the reasons why. So first of all, you have angle 58, and you're being asked in the first one to calculate the angle AOC, meaning this angle over here. For this triangle. So for this triangle, you're being asked to calculate this angle. So we'll call that angle over here x. And basically, to calculate that, this angle x is nothing but 2 times the angle here. Now the reason for this is, if you look, both triangles are in the same segment. The only difference is that this triangle goes only to the center, meaning this angle is twice the angle over here. So that means that x is equal to 2 times 58, which is equal to 116 degrees. And the reason for this is, in the second question, angle at center is twice the angle at circumference. Just right, yeah. Alright, so question 15b1 is asking you to find this angle here. We'll call it y. Okay, so if you look at this shape, first of all, as a whole, it's inside a circle, so it's cyclic, and it's a quadrilateral because it has 4 sides. Okay, so you know that it's a cyclic quadrilateral. So what do you know about cyclic quadrilaterals? Basically, their opposite angles add up to 180. So that means that equal to 180 degrees. So that means that 116, since these two are opposite angles, that means 116 plus y should add up to 180. So that means y is equal to, subtract 116 on both sides, 180 minus 116, and so y is equal to, sorry, I don't know what I just did, I'm like a stupid guy. A cyclic quadrilateral is a quadrilateral which all four edges touch the side of the circle. Sorry, not the center. Don't forget what I just said. One of my silly mistakes again. So basically, opposite angles should add up, we'll call that y, opposite angles should add up to 180. So these two are opposite angles. So in this case, 58 plus y should add up to 180. So y is equal to, subtract 58 on both sides, 180 minus 58. So y is equal to 122 degrees. And the reason behind this, which is 15b2, it's because sum of opposite angles of cyclic quadrilateral, just write quadrilateral, I'm too lazy, equals 180 degrees. And a cyclic quadrilateral, remember, is where all four sides of the quadrilateral are touching the edge of the circle, which makes it cyclic. So question 16. There are 10 chocolates in a box, and 7 of the chocolates have soft centers and 3 of the chocolates have hard centers. Meaning the probability of, out of the 10 chocolates, 7 out of 10 will have soft centers, and the probability of getting a hard chocolate is 3 out of 10. So first of all, they're asking you in 16a to complete the probability tree diagram. So let's just fill in this part, because we already know it. Now, they also say that when this girl Kyla over here, she takes a chocolate out of the box, and after she takes it out, she eats it. So that means that the chocolate is no longer there in the probability. Okay? So then, for the second chocolate again, she does the same thing. She takes the chocolate out of the box and she eats it. So first of all, you have to complete the probability tree diagram. So let's first of all go on this path. So let's say she takes the chocolate with a soft center out of the box. The probability of her initially taking that out of the box is 7 out of 10. Now, again, the second probability, she'll only get to take a soft center or a hard center again. But now, let's say she takes a soft center in the first time. So there's a box of chocolates. There's a few soft centers. So let's say there's there are 3 out of 5 soft centers. She takes this soft center out of the box. Now all of a sudden there are 2 out of 4. So basically you can see the probability has reduced. So basically since there's 1 less soft center, that means that there should be 6 out of, and there's also 1 less chocolate, 9. And if she takes a hard center, there'll be the same number of hard centers, but over a smaller amount, 3 out of 9. Because 1 chocolate has gone out of the box because she ate it, she didn't put it back in the box. So there are 9 chocolates now, over here, and of them, there are 6 soft, and the hard centers stay the same. Now the same thing if she takes a hard center first. She can either take a soft center on the second choice, so soft C, or a hard C. Okay? So let's say she takes a hard center out of the box. The probability of her taking a hard center the second time would be 2 out of 9, because the number of hard centers has reduced, because she's taken this hard center out of the box, and she's eaten it. So there's now 2 hard centers, and plus there's 1 less chocolate in the box. So there's 2 out of 9. So that's why this is 2 out of 9. But the number of soft centers stay the same. So it stays at 7 soft centers out of 1 less chocolate. So 7 out of 9. So this is the completed probability tree diagram for you to copy. Okay, 16b, you're being asked to calculate the probability that at least one of the chocolates Kyla eats has a hard center. Now the key word is at least. It basically means that at least 1 or more, meaning 1 or 2 chocolates with hard centers. So first of all, you have to look at the possibilities that could occur when she eats 2 chocolates. First of all, she could eat a soft center, then she could eat a hard center, so at least 1 hard center is being eaten. Then another possibility is where she could eat a hard center in the first try, and then eat a soft center in the second, so that's at least one hard center eaten. Or she could eat both heart centers. So that's at least, at least one heart center has been eaten. So now you got to calculate each of these probabilities separately. Okay? So first let's deal with soft center and then heart center. So if you look at your probability tree diagram, the first probability of eating a soft center is 7 out of 10. So then if she eats the first soft center, that means there's no less heart centers. So that means that the next probability of eating a heart center is nothing but 3, because there are 3 heart centers, but there's 1 less chocolate because she's eaten the soft center, so 3 out of 9. Now you got to add this to this probability over here, and we're going to calculate that now. So the probability of her first eating a heart center is 3 out of 10. And then a soft center, the number of soft centers will stay the same, so it's 7, but there are 1 less chocolate because she's taken this heart center. She's taken 1 chocolate out, so it's times 7 out of 9. Then you add this to heart center, then heart center. So at first, if she takes the heart center, it's a 3 out of 10 probability. But then there's 1 less heart center, so there's 2 heart centers out of, and there's also 1 less chocolate, so 2 out of 9. So you got to add this all together to get a value for the total probability that she eats at least 1 heart center. And that answer is 21 out of 90 plus 21 out of 90 plus 6 out of 90, and you're going to get 48 out of 90. And that's your answer. Alright, so we're done with part 2. Please go on to watch part 3 for paper 4H from November 2009, and comment, rate and subscribe, and see you guys on the next video.